Hello class, this is your TI Athen. I'm attempting to teach you guys about how the cell cycle is controlled by internal and external mechanisms. Without it, this could lead to cancer. So you don't want cancer obviously in your cells, and it's very important to try to restrict this, and your body does a pretty decent job at it. It's actually pretty well orchestrated, and it has lots of restrictions and checkpoints to make sure that the body does not develop cancer within the cells and does not pass it on. So as the title says, just wing it and don't get cancer. You really want to make sure that your body stays healthy, and you want to learn this stuff pretty well. Alright. The cell is highly regulated. The cell can also be divided up into select parts. You see right here you got G1. G1 is the actually first four phases of the cell. In this part, the cell synthesizes mRNA and proteins in the preparation for steps leading to mitosis, which is right here. Obviously, we're moving around in this clockwise direction. Okay, as you can imagine, it is extremely important for this cell to get it right. You want the cell to make sure that it does not mess up this G1 early stage, or else it could be obviously catastrophic to the cell in the later stages. So we have a checkpoint actually right here within the G1 to make sure that everything we need, it goes well. If we do not get what we need in this process, if we don't have the right proteins or any other required substances within the cell in order, the right DNA, any kind of problems, then the cell actually will stop this entire process and just abort the entire thing. If it aborts this entire thing, it will go to the GO stage, which is not listed on here, but the GO stage, it's a lot more like a stalemate stage, which actually a decent amount of our cells are in. They stop reproducing, they've already hit their full peak or whatever. So yeah, that's where that cells is. So a good analogy for this G1 stage is a lot like a copy machine. You don't want to start off with a bad copy, because once you get that bad copy and you just keep copying it over time, it's going to slowly get worse and worse, or it could be cancerous and it could have negative effects. So we want to keep this G1 nice and good, and that's why we have this good checkpoint right here. Okay, in order to make sure that all the clones, I'm sorry about that. In order to make sure the DNA must be replicated for the 2. This is what the S phase is. This S also stands for synthesis, if anyone doesn't understand that. So this entire S phase is important to synthesis, my apologies. It does not have a checkpoint, okay? There is no gap between DNA and, there is a gap, my apologies. There is a gap between DNA synthesis and mitosis. This is the G2 phase. They will continue to grow and make new proteins. The checkpoint makes sure that the cells do not go into mitosis before they have a chance to repair damaged DNA and replace themselves. So basically, the way I see the cell, it's a little bit of a crude analogy, but it's kind of like the making sure people don't have sex before they're ready. I know it's kind of an odd analogy, but it's kind of like you want to make sure the cell is in the right position, it's fully mature, it's got all the everything it requires in order to split before it just kind of starts doing so. So it's very much like a requirement in order to continue. So yeah. Next we have the mitosis. If you don't know what mitosis is obviously the cell splitting into the 2, and we've talked about that, I'm sure, in class. You should know that. The M says make sure that the sister chromatins are correctly attached before entering the anaphase stage, because once you go into the anaphase, you can't come back. All of these things are highly regulated. So basically, the whole point of the M checkpoint is to make sure everything is correctly in position before attempting to move on. It's kind of like the seatbelt, I guess you could say, of the cell. Regulation cycle. You want to make sure everything's correctly done before you continue on. Okay, so yeah, as you see here, this would be a checkpoint. You're really trying to make sure that nothing gets by before you want it to. Alright, so let's say something we've already talked about in the M stage, but let's say something gets by anyways. Something kind of hops the wall and gets by. What do we do then? Alright, so right here, this would be, your green light go. You got all the right proteins, all the right, we'll talk about that in a second. Everything that you need in order to move on. So let's say what happens when you don't have all that? And your body signals, no, stop. Well, basically, the entire process would cease where it is, and the cell would stop replicating. Or that's the ideal situation. If it doesn't, you actually get cancer. And cancer is obviously not good, as it's uncontrolled cellular reproduction. And, it'd be really bad. When you have cancer, you don't make good decisions, and everything's clouded and it's poor. Your body isn't functioning right. Let's say you have brain cancer, you make a bunch of stupid decisions. It'd be like, you make dumb stuff like giving Monkey a machine gun. Yeah, I'd say it's a pretty safe assumption to assume that one of those guys has brain cancer in order to make that decision. So, yeah, obviously, cancer is not good. Alright, so within here, you can see this is actually the process in which it requires everything to, what you have to do. So here in the specific part, you have your CDK, which is cyclin-dependent kinesis, which is basically means it's dependent on this cyclin in order to continue on, which makes MPF, which is maturination promoting factors. So basically, this is actually what promotes in G2. It's what gets past the checkpoint in order to allow the actual cell to begin the entire system around. Now, cyclin is like, imagine a bus. The cyclin are the passengers on the bus. They move through and then they get dumped off, right? The CDK is the bus, and it's going to keep going around its process, and once it gets to this bus stop, it will not continue until it has more cyclin, okay? So the whole thing is you want to get rid of the cyclin after you get to this point. And what a typical cancer would do is once you get to this point, the cyclin isn't degraded, so the cyclin just stay on and it continue this process. And because it's continuing this process so many times, the cell isn't even close to ready to be able to reproduce anymore, but it does it anyway since it's getting past this checkpoint. So a lot of cancers actually have to do with the fact that it's not abiding to the rules of the checkpoint. Okay? So it's very important that we make sure that our cyclins stay in balance, and as you can see, this is the part we were talking about earlier where the whole, this whole part right here, the mitosis, that's it, my apologies for that stumble on the words. So obviously, if we skip past this point and it's not ready, then it's going to have detrimental effects, and it's just going to continue this process and pass down this whole not working with the cyclin. And that's what makes the whole MPF, the whole bus, and everything. Yeah, so molecular mechanisms that help regulate the cell system. So these are the systems that help regulate it and actually are what makes the checkpoints work. They don't just work on their own. You actually have to have something passing through them. Or that's just one of the examples for checkpoint 2. Yeah, okay. So as you can see in this analogy right here, these are all the cells, and these are non-cancerous cells. As you can see, they're taking up the provided amount of space, and they don't want to continue expanding until they, they fill up the dish and then they stop. And right here, as I was saying, this is the example of the density-dependent inhibitor, and that shows non-cancer growth as it's limiting itself and not over-expanding. While cancerous cells would continue to expand into this area, and that could show how the checkpoints were not being used correctly, and how it was just allowing unlimited growth. And that's important with the use of the PDGF, which is the platelet-derived growing factor, which is, that's a bit of a more challenging thing to say. But yeah, that's what really limits the amount of cellular growth in the areas and works together with the checkpoints. It's very important for the cell. It's what really shows that. Sorry, my mic came unplugged there. I think I accidentally stepped on the cord. My apologies. Alright, and just so we really understand what that cyclin process I was describing before, this is an example on the different types of cyclins have different locations. It's not all just within the G2 and the G1. It's all around the entire cell. It shows how it's constant effect. So yeah, that's basically everything. Just so you know, that's how cancer really takes hold of the cell. Because there's nothing that limits the fact that the cell is rapidly reproducing, it just passes on the gene telling it to rapidly reproduce, and that causes the cancer to spread. And as the cancer cells spread around the body, obviously they're going to reproduce faster than normal cells since they have nothing to actually do besides reproduce. So yeah, that shows how obviously it shows the complicity of how our body limits on how cancer spreads throughout the body and how it spreads in the cells through lots of checkpoints and systems in which it checks to make sure that no cancer is there and that the cells ready to reproduce. I hope you learned from this video, and I'm happy you watched it.